That's adorable. That's adorable. Hey, we're going to skip this top section right here, so you can go ahead and cross that out. You can go ahead and cross that out. All right, there we go. There we go. But let's go ahead and talk about, so a beaker is awesome at holding liquids, but not for measuring, especially. Not great for mixing. Not great for mixing either, but you can sometimes stir in them, kind of thing. But measuring, definitely not. Now you want to read the number above the shape on the right for the size. So if I'm like, Sophia, will you go ahead and give me a 400 milliliter beaker? She's like, well, it goes up to 300 here, but it says 400. Which one is it? This is your true label right here. This guy right here on the side. Okay. Now it goes up to 300 on the numbers, but that's just kind of letting you know. So like you see the 300 here, and there's some space above. So this is about 400 milliliters. So that way, you know when I say, hey, get your 150 milliliter beaker, get your 250. Like this is the label that kind of tells you that. Does that make sense? And you should never fill them more than about halfway. Now, if Anthony comes in and he puts 201 milliliters in his 400 milliliter beaker, like that doesn't really matter. That's okay. It's a general rule of thumb. But he probably shouldn't be putting 275 milliliters in it either. Does that kind of make sense? Okay. So it's not like this hard and fast rule, like is that 201, like about halfway. Yes. So right here, what I'm about to say is the first thing that's on your notes. Cool. Got it? Sweet. Okay, so graduated cylinder will measure volume. And what are the units on graduated cylinders?
10 units.
What units are they?
Centimeters.
Not centimeters. Milliliters. Lowercase m, capital L stands for milliliters. You better be slapping milliliters on everything today. Okay, that's what we'll be using. Yes, ma'am? It's M-I-L-L-I, L-I-T-E-R. But you can always just put lowercase m, capital L.
Why is it a lowercase m and capital L?
Because this is the prefix, and the L is what it's really about. So this is a liter measurement, particularly milliliters, but sometimes you just have regular liters. Sometimes you have kiloliters, that kind of thing. It looks a little goofy, yeah, but it's just a nomenclature thing. Now you should always rinse your graduated cylinder between uses. This is pretty important, okay? So if you have your graduated cylinder, you're measuring some chemical A in here, you pour it into your beaker. You want to make sure you rinse it before you pour chemical B in here, because chemical A and chemical B could have a chemical reaction, and that could be a big problem for you if that happens in your graduated cylinder, okay? You want to avoid that. Now, you don't have to like thoroughly clean your graduated cylinder between every time. So let's say, hey, this is chemical A, pour that into my beaker. Here's what you could do before chemical B. You could just be like, yeah, just a little bit of loving. All right, let's get some chemical B. It doesn't have to be like this full-scale clean. You just want to rinse it out a couple of times so you don't get any mixture, okay? Now, when you are asked to measure something, some sort of liquid volume, you want to make sure you use the most appropriate graduated cylinder, because you often have choices. So in your drawer, you'll always have the 10 milliliter and the 100 milliliter. So for example, if I ask you to give me 7 milliliters of something, the 1,000 milliliter graduated cylinder, that's probably not a very good choice for that, okay? But the 10 milliliter graduated cylinder is probably pretty nice for that, okay? Because you only have to fill it up once. The increments on 10 milliliter graduated cylinder are pretty small, so you're going to have a small margin of error. If I asked you to get me, like, I don't know, 27 milliliters of something, what do you think is the best graduated cylinder on this list to use?
100 milliliters.
I'd probably go with the 50. It's like the closest to it. Sometimes you won't have that option like today, and you probably want to go with the 100. Why not the 10? Well, if you use the 10, which you can do, but if you use the 10, you're going to have to fill it up 2 times in a row and then 3/4 of the way a third time. That's 3 different measurements. That's 3 opportunities to have an error in your measurements. And you usually want to have less measurements when you can, okay? Now, there are some judgment calls. So if I'm like, hey, Gloria, give me 127 milliliters or something. She's like, do I use the 100 or 1,000? If you use the 100, you'll have to measure twice. But the increments on the 100, like that's going to be a lot closer to the 127 than it is on the 1,000. So it's kind of a judgment call. So if Glory uses the 100, Grace uses the 1,000. I wouldn't say either one of them's wrong. That's kind of like a toss-up, okay? But you certainly don't want to use the 10 for this either, because you're going to be filling that up 13 times, okay? And that's really not great practice. Does that make sense? Okay? Now let's talk about how to read these graduated cylinders. Boom. Oops, I got to skip. Oh, yeah, the increments here. So different size graduated cylinders, the tick marks mean different things. So on this first one, we have 10 tick marks between the 0 and the 10. So what does each tick mark represent? One what? Milliliter. Boom. Okay?
Millimeter.
Yep. Yeah, nice save there. On this one, we only have 5 tick marks between the 0 and the 10, so each tick mark represents a 2 milliliter increase. Okay? What about 5 tick marks between the 0 and a 1? 0.2. And 2 tick marks between 0 and 1 is 0.5 milliliters, okay? You'll notice that only like on your 10 milliliter graduated cylinder, only 10% of the lines are actually labeled. So it's really important that you know what each tick mark means. What do you want, Miss Bay? Oh, you got it already? Okay, all right, good talk. She just usually hits the wall. She's so unprofessional. No, I'm just kidding. Not really, but kind of, sort of. Okay, anyways. Now let's talk about how to actually read. So there's this thing called a meniscus. Like what I tore in soccer practice last year? No. In chemistry, we're talking about the curve in the surface of the water. So the meniscus refers to the curve in the surface of the water. So it's hard to see unless you're right by a graduated cylinder that has some stuff in it, but it actually has a curve. Okay? On the sides, it goes up higher than it does in the middle. So it's like, well, do I read up here where it reaches on the sides, or do I read down here where it is in the middle? And what you should always do, the key word here, is you should always read at the bottom of the curve. You want to read at the bottom of the curve. So, Mr. P, what is the best way to do that? Well, I'll tell you the best way to not do that, or not the best way. You don't want to hold it up like this, because unless you're holding it up perfectly straight, it's going to have a little tilt, and that's going to give you an inaccurate measurement. You're going to have to get on the elevator. If you're tall like me, you're going to have to, you want to be at eye level when you read these things, okay? So that's the best way to get the reading of the curve. It's flat on the table. You want to get an eye level reading. Does that make sense? Okay? So you're going to kind of be on the elevator a lot today because you're going to be looking at your 10 milliliter graduated cylinder and also your 100 milliliter graduated cylinder during lab today. Boom. Okay. Now, what do we do when we're getting those measurements at that eye level? Okay. So key things, you always want to read one place after the last line you know. Okay, we need to estimate. And I'll show you exactly what I mean by that. Now, I've broken some trust because I had a couple of trick questions earlier today, but this is not a trick question. You're like, wait, that's exactly what he'd say if it was a trick? It's not. Would you guys bet me $1 million that this reading is 60-something?
Yes.
Yeah, I would. It's for sure between 60 and 70. Yeah, I would, for sure. Would you bet me $1 million that it's 63-something? Yeah, I would. It's definitely between 63 and 64. You see that meniscus? Clearly in between 63 and 64. So it's definitely 63-something. Now, would you bet me $1 million at 63.7 and not 63.8? I probably wouldn't because that's an estimation. You don't know for sure. So in my estimation, I think that's a 63.8. Of course, I'm throwing the milliliters on there. Now, if Riley says 63.7, she's just as correct as I am because we're estimating that very last point, okay? Now, these first two we knew for sure, and this last one we estimated. So what you need to do is you need to give me every number you know for sure and then estimate one spot after what you know, okay? Now, what would be incorrect here is if you said 63.1. Like, we know it's clearly not 63.1, but is it 63.8? Is it 63.7? Like, that's kind of a judgment call, and so you need to estimate. Like over here on this guy, I bet $1 million at 70-something, and I bet $1 million at 79-something. I would even bet $1 million at 79.1-something, because it's definitely between the 0.1 and the 0.2. Like, we know that for sure. And so since these increments go to the 10th place, we need to estimate all the way down to the 100th place. I think it's about 0.15. But if Danielle was like, no, it's definitely 0.14, I wouldn't really argue with that because we're both kind of estimating at that point. Now, if Ryan said it was like, oh, it's 79.19, like, well, it's clearly not like 0.9 at the very end there. But 0.15, 0.14, that's kind of a toss-up, in my opinion. Now, every now and then, this happens about 10% of the time, you will have one that sort of lands on a line. So I know it's 30. I know it's 32. And honestly, I think it lands on the line itself. You need to actually write that 0.0 there. Here's why. If Sage tells me that she has 32 milliliters or something, what that means she's like, okay, I know it's 30-something, and I'm pretty sure it's 32. It might be 31, but I'm pretty sure it's 32. But if Harry tells me it's 32.0, what he's saying is, I know it's 32, and I'm pretty sure it's 0.0. Do you guys see how it's a little bit different? It's a little bit more precise on that second one. So you want to watch out for that. Now, you guys do have a little bit of practice you guys can do on this worksheet. The answer key is posted online. Lots of times I'll print those answer keys out for you. You guys can try those later if you feel like you need to. I don't want to spend time on class doing that because I want to get to the mixing lab. And if you're at home listening to this lecture, you guys are good to go. I will see you when you come back.